Okay.
Okay, so I just started recording. So, hello everyone. Thank you for joining this
Mm-hmm.
P4 Brigade call. Uh, Hopefully, it won't be that long today. So, we have three main items in the agenda: Fabric.P4, INT, and unit test. So, regarding Fabric.P4, Yi here from ONF has been doing a lot of progress in adding support for Fabric, Fabric.P4. Last we architected the pipeliner implementation, um, and now it's a bit more modular. We're able to support different forwarding use cases. Uh, can you give us a little update on the status of the Fabric
Yeah,
before? Which use cases we do support and which don't?
okay, so currently I have a patch and I always also have a draft document. It's work in progress. Um, so currently there's a patch Garrett which supports Algerian cast and Algerian cast. And about Algerian unicast, it also supports uh, course leave, which uses APIs with ECMP feature course leave to send packet to different subnets. I can do a quick demo now.
So I can make you presenter.
Yeah.
So yeah, we'll have a little demo of what we have so far, and then I'm going to talk about a new task for which we're looking for help.
Um, just give me 1 second. So, so currently we have a ONOS with this patch, and we just need to enable BMV2 driver and the Fabric pipeliner pipeline, yeah, and also host location provider and LD provider, and also proxy.
Okay.
We just first we just enable these
Application.
applications, then we start the Minet. Also,
Just to clarify, this routing trellis repository you were on, this is the one that it's on GitHub, right? That everyone can use to run the experiments.
Yeah, also I have a patch for the trace.p4.py Minet script, also on Garrett, but I think we will merge very soon. Just few things to fix.
Okay.
And yeah, so you can find on our GitHub, which location is ON.Lab /routing. GitHub is now ON.Lab. ONOS is ON.Lab routing. I'll show you guys later. So basically, just need to start trace.p4 with ONOS IP. So my IP is 2.1. Okay, just start it. Yeah, start it. So you will start four switches, which is a 2x2 list spine topologies. We can see here we have four switches. Also, because currently Andrea is working on the message stuff, so sometimes you will see the available is false. So basically, the temporary uh, fix is to do forcing the message stream again by using command line. So you just use device row, for example, the BNB2204, 204, and the master node you want, and then master row. So after you do this, after a few seconds, you'll just become true.
Okay.
Yeah, so it's just temporary.
So this applies also to the problem that is seen have seen in the mailing list.
I think maybe.
Yeah. Okay.
Yeah. So.
But so Andreas patch should solve this problem, right?
I don't know. Maybe yeah.
Maybe Andrea. I mean, maybe we can talk about this later. Yeah.
Yeah, and 227.
Yeah, if you can test it with my patch, that would be great, and give me some feedback. I would like to hear that.
I can test offline.
Okay, sure. Send me an email.
Okay, sure. So everything's true.
Okay.
So you can check there's a flows installed by the host loading provider, LDP provider funcks up. It's like R, BDDP, and LBD. And currently, if you want to make everything faster, because currently we use the polling mechanism to pull the for rows and the groups by about 30 seconds, right? So we can set the polling frequency, the time. Just use CFG sets ONOS project, nets, flow, implementation for row measure, and the fallback flow for frequency. Like I would just set to 10 seconds, it's fine. Also the groups, so it's ONOS project, nets, group measure, and it's set fallback group pro frequency.
But just to understand, if someone wants to reproduce the same demo, Fabric.P4, do they need to do this operation? So,
no, but I want to make it better.
okay.
So, yeah. Okay. Also, so currently we can just try let the owners run the host. So we need to make host 1 ping host 2. Also, the host will learn the ARP for this for setting up subnet, and host 3 ping host 4. So basically, this topology, host 1 has to are in same subnet, and host 3 and host 4 are in same subnet.
Have you ever shown the
Topology?
the configuration file?
Oh yeah. So I haven't pushed the topology file.
So right now you start the ping such that ONOS receives the ARP request and discovers the host, right?
Yeah, so you can see the host on my screen. There are 4 hosts from host 1 to host 4. So host 1 and host 2 are in same subnet, which is 10.0.10 0/24, and the host 2, host 3, host 4 is 10.0.10 10.0.20 0/24.
Okay.
And also have links. So maybe I can just show the topology. Let's see. Show the screen. Yeah. So you can go to the ONOS-P4 and see the topology looks like. So basically we have 2x2 list lines looks like this, and we have 4 hosts. So yeah, so host 1, host 2 are in same wave and with same subnet. Host 3 also are in same wave and same subnet. But you can do you can put hosts with different subnet in same wave. It's also fine. Yeah.
Okay. So just can you click on one of those so we can look at the IP address? Okay, so this is 10.0.10.01. Yeah, 10.0.10.01.
Yeah.
Okay.
So next step is to push the network configuration. So let me show network configuration first. So we have P4 trace P4.json. Okay, so it basically set the interfaces for each port. For example, the 204 third port, this port connects to the H1, so I just put the name of the interface.
And just to clarify for people that don't know very much, Charlie's, this configuration is used by the segment routing application, right?
Yes.
To generate the flow rules and.
Yeah. So this configuration contains interface configuration and the segment routing configuration.
Okay.
Yeah, and the segment routing application will use interface configuration for the subnet configuration. Yeah. So the port connect to the H1, which contains the IP. This means this port will act as a virtual gateway. So if you take to at the host 1 routes of the host 1, you can see the default gateway we put is 10.0.10.254, which is sent as the IP address of this interface. So if this host wants to send packet to different subnet, you will go to this gateway, this virtual gateway first. And the signal routing will knows, because the host will first get the MAC address of this virtual gateway, and the signal routing will reply the virtual MAC address, the MAC address of this virtual gateway. And the signal routing will use this MAC address as the Ethernet destination to see if it wants to do the routing or do the bridging.
So now you will show how to ping hosts both in the same subnet and different subnets?
Yeah, I can show this now. But one more thing is we have different VLAN configuration for subnets. Okay, also we have signal routing configuration for different leaf and spine. And so for each leaf is act as edge router, so we need to set edge router true, and we need to give the router MAC address for this leaf, so we can reply the virtual route MAC, virtual gateway MAC. So if you want to need more information, you can take to the documentation of the trellis. Yeah, so I think I can do the demo now. So push the configuration, you just need to use ONOS-Net CFG with IP address. For example, I run the ONOS on my computer, so I just need to do put the 0 is fine. And trace P4 JSON file. So after you push it, you will see interfaces configuration here. Also, because currently I haven't activate the signal routing application, so the signal routing will be queued after. So after the application activate, you will the app will receive the configuration again. Okay, so let me activate the signal routing application. So how you will see is the application will initialize the flow rows for objectives and groups first, and after a few seconds, we'll see the group's events and the group installed event here. So we can see those, for example, the one of these. Oh, those. Maybe just 204. Yeah, so we can see basically for the bridging, we can find the bridging rows from the forwarding bridging table. These two rows is for the host 1 and host 2. So we will do the bridging. And for routing, we can find 3 rows from Unicast V4, which matches host 1 and host 2 IP address, and also matches the different subnets. So you'll go. So for example, the different subnet, you will go to next ID 12, which we use the next ID as group ID, so we can just check the groups. 204, yeah. So the groups ID 12 contains 2 buckets, which also this is a select group, which will do the ECMP based on currently we design based on tuple, and what do is to send to the different spine switch, and so the Ethernet destination is the spine switch MAC address we set to the signal routing conversion, and do the output with destination leaf. We put the destination leaf ID to the MPLS table, and the spine switch will match this table, and then you will know which leaves you will send. Yeah. And let's just quick to look at the spine, the flow rules on the spine.
I mean, the bottom line here is that the configuration of each leaf and spine is very complex in terms of like the number of flow rules and groups.
Yeah.
And that's a result of the pipeliner translation.
Yeah,
right?
yeah. So the pipeliner and also the interpreter help us translate. Yeah. So okay. Let me explain the comment. The dash S is simplified version, which not showing everything on screen. And dash N is ignore some rows installed by the core. For example, we use the packet request to request up row and the LDB rows. It will be ignored by dash N. And any is the state, which the states here, any state. And then finally we add the device ID. So what we need to look is the MPS table, which is this kind of table. We see a lot of rows because the second round here will also try to push the pseudo wire for rows. So we can find like 1, 204 and 1, 205 and the 215, 214. But we don't need to clear this. We just need to clear the 204 and 205 label, these two currently. Yeah, so if we want to send the packet to leaf 205, you will do the next ID 13 and which is this one, I believe.
Okay.
Also, because with the similar design, we can support multiple links between send leaf and send spine. So it will also use the ECFP group, which is here. But currently it's just only one link. So the group will only do the one extra bucket, have an answer. Yeah. Okay, so let me show the pinging. Yeah. So what I will do is to generate four combination of the pinging, which is host 1 ping, host 4, host 3 ping, host 2, host 4 ping, host 1 maybe. So this is host 1, this is host 2. Oh, let me just ping host 1, host 2 first.
Yeah.
So host 1 ping host 2 is the L2 case, and also host 3 ping host 4.
So your packets are being forwarded directly by the same leaf switch.
Yeah.
In the layer 2 unicast table, layer 2
Yes.
bridging table of
Fabric.P4.
Okay.
Yeah. And if you want to do the cross leaf across some nets, just like host 1 ping host 3, so it's fine. Yeah.
So this is crossing the spines too in this case.
Yeah, and because currently there's, I think because the source and destination, and I think the port are same. So you only do the send path. So what I'm doing is to generate multiple kind of combination, like host 1 ping host 3, 20.1. This is host 3, and host 2 ping host 4, and host 3 ping host 2. And host 4 ping host 1. Also, there's a very useful tool from Minet called Minet UTM, which allows you can access to this network space.
Okay, so I see Serkant is online. Okay, great. I know he has a big presentation, so if we can wrap it up, so, because I also have to present another task.
Okay, so you can see everything works fine, and so currently ONOS is very stable. Not everything, nothing.
No exceptions.
Yeah, but okay. So currently I haven't disabled the link local address of host, so you can find the link IPv6 link local address, but it's fine.
Okay.
And then we can see just refresh the GUI. So because currently it's just pinging, so we just need to see the packet per second here.
And that's because in the P4 program you define port counters, right?
Yeah, we define port counters. So you can see the traffics go through different links path.
Okay.
Yeah, so it works fine.
Okay, that's amazing. That's amazing. So we already have a version of Fabric.P4 that supports layer 2 unicast, layer 3 unicast, and MPLS. I mean, when we say layer 3 routing, we implicitly saying that this is done using MPLS based segment routing, right?
Oh yeah, so so we support this. So we have some tasks. So first is the implementation of L2 broadcast.
I'll talk about this.
Okay. Should I return the? Return. Oh yes.
Yeah.
Should I start sharing? This one.
Okay, so is there any question about the demo that you just showed?
Let me ask you a question.
Yeah, sure.
Which forwarding functions did you implement to realize this demo?
So currently there's only L2 unicast and the L3 routing. We have two kinds of forwarding. Like one is different subnet in send leaf, and the other is different subnet written in different leaf. These three kinds of forwarding.
So I would say these two, right? The one in the pipeline implementation you call layer 2 unicast and layer 3 unicast.
Yeah, and currently we only support IPv4.
Okay.
Yeah, so but the logic I think is set to support IPv4 and IPv6.
But IPv6 is not implemented yet. Right? So this is, for example, a task that Yassine or the other members of the working on this can implement. Okay, so
yes, we can share. Excuse me. Yes, we can share the rest of the forwarding functions implementations, I think.
Yeah, definitely. So I'm going to talk about like a task for which we need help. So maybe Yassine or anyone else from the working group. I mean, you guys can help. So this is one, but there are definitely more. So I'll talk about this case. So you talk about what we call layer 2 unicast. There is another forwarding function we want to support, which is layer 2 broadcast, which is used to mostly manage HARP requests.
Yeah.
So what happens today is that in the demo, we were able to have the two hosts pinging because in ONOS we have an application called ProxyR that intercepts all the ARP requests and replies by forging an ARP packet with the information of the requested by the host. So this is currently managed by ONOS, meaning that every ARP request is sent to ONOS as a packet chain and it's managed by ONOS. Now, clearly this solution works for demo purposes, but it's not very scalable. Indeed, in the current cord fabric, so Trellis, based on FDPA, ARP requests are completely handled by the data plane. So what happens is that we want two things. We want to be able to broadcast ARP requests to all the hosts of the same subnet, so connected to the same leaf. Is it possible to broadcast requests to hosts? Is it possible to have hosts of the same subnet connected to different leaves?
No.
Okay. So what we want to do is first broadcast the ARP request to all the hosts of the same subnet, so connected to the same leaf. But at the same time, we want to be able to clone that ARP request packet and send it to ONOS. So at least ONOS and the host provider application is aware of that ARP request. They can discover the host. Now, the problem is the following. P4 and P4 Runtime does not support the packet replication process that is needed for broadcast. So packet replication, right? Let's say broadcast and in general packet replication, these are target-specific features. And they're usually implemented in what is called the traffic manager of a P4 architecture. So let's take the example of DMV2s. The simple switch target. In the simple switch target, we have the pipeline comprises a parser, an ingress pipeline. Then we have the so-called packet replication engine, PRE, and an egress pipeline, and a deparser. Now, the ingress pipeline and the egress pipeline, those can be controlled using P4 runtime, right? That we use to do mostly table management. Where we enable packet replication and so broadcast, this is in the PRE, packet replication engine. And this is not, we cannot control this using P4 runtime. Now, there is some discussion in the P4.org API working group about the fact if P4 runtime should be offer APIs to control the traffic manager or not, or if this should be left to other interfaces like GNMI. There's no answer yet. This is still work in progress. The bottom line is that if we want to configure broadcast on a P4 device, then that configuration is target specific. For example, BMV2 offers a Thrift-based API. You can find this link. If you have a look at this repository, there is a file called Simple Packet Replication Engine. In here, you can see messages, for example, to create multicast group, destroy multicast group, things like that. Other P4 targets offer a very similar interface based on Thrift. So the idea is that we start by adding support for the packet replication engine, BMV2 packet replication engine in ONOS, and then we can use the same code for other targets. So the approach we're proposing here, and feel free to comment on this picture. I drew it last night while I was very tired. So the idea is that today we have the segment routing application running on top of the ONOS core, sending down flow objectives. The flow objectives are processed by the Fabric pipecom, the one that he created, in which we have a pipeliner that then uses, let's say, different handler to translate objectives for the different forwarding function types. So the idea is to have existing flow objectives that produces table entries and select groups. So the select groups are those used to implement like equal cost move the path, like you showed in demo. The idea is to have those entities, so table entries and ECMP groups, to be handled as of today using the, let's say, P4 runtime subsystem. So we have in the BMV2 driver, the BMV2 driver uses a so-called P4 runtime flow rule programmable or group programmable that then uses the P4 runtime client to talk to a device. The idea is to have then broadcast groups instead handled by different paths. So the idea is to have first a layer 2 broadcast handler at in the pipeliner implementation that then uses a Thrift client that is maintained by the BMV2 driver to instantiate groups in BMV2. Now, this is very high level, but the idea here is that we need to implement first a Thrift client for that PRE interface that I showed you before, this one, and handler in the pipeliner implementation that understands flow objectives, uses to specify those layer 2 broadcast rules.
Camillo, just one quick question. When you say a Thrift client, is this a one per session of the device or one client per call?
Good point. We can discuss about this. There's no need to keep that connection open because differently from P4 runtime, we're not receiving packetings or other information from the device on that channel.
Yeah, that was my same assumption.
So this could be a client that we instantiate each time we need to configure BMV2, and then we can shut it down, definitely. Yeah, good point. Yeah. So at a very high level, the steps to implement this are the following three. First, we need to auto-generate the Java code for the Thrift interface. Again, this one. And this can be done using Bach in ONOS. I remember working on something similar a few months ago, but then that patch never got, we actually abandoned that. So maybe I can look into Garrett
Yeah, the abandoned patches are still there. It's just owner Carmelo status abandoned.
Yeah, so there is already a patch that builds the BMV2 thrift stuff for Java. Then the second step is to implement the BMV2 packet replication engine client that will use the auto-generated BMV2 thrift stubs. And this client will be used to, of course, interact with PRE to create, modify, delete multicast groups. And then we need to implement the layer 2 broadcast handler in the pipeliner. So these are the high-level steps. If there's anyone that wants to help with this task, please feel free to reach out to the mailing list to ask more questions on how to do that. And yes, as Yi said, we also need help to implement things like layer 2 unicast with IPv6. Okay. So, is there any question about this?
Yes, hi Carmelo.
Hi, Serkan.
What if we just don't use the broadcasting?
Well, the thing, yeah, go ahead.
Yeah.
So right now, as I said before, for demo purposes, it works. So if we have a bunch of us connected to ONOS, then we can use the proxy ARP application. It's easy to demo things. But if we want to bring this fabric to a production level, like the OFDPA 1, then let's say that users of the fabric really prefer having broadcasting of ARP requests handled by the data plane. They don't like the controller to be,
I think
overfloated with ARP
I
requests.
think the focus is first step because also we need to support multicast.
Exactly.
Yeah.
So the same work, so this PRE client can be reused to support layer 3 multicast.
Yeah.
That is, for example, used in our court, residential court for IPTV, right? In which you want to split the same video flow to different endpoints. So that's why we need to support configuration of the packet replication engine from ONOS.
Actually, I mean, maybe we can disable broadcasting in the switch. In our implementation on ONOS, we actually disable the broadcasting and modified the proxy ARP. Maybe Asin better explains than me. We just sent one ARP packet to the proxy ARP. Then, because we know which MAC address has the IP address, then we'll just forward the ARP messages to the correct destination. Esin, do you want to talk about a little bit?
Yes, we arranged, we rewrite the proxy ARP application, and we completely disabled the broadcasting in our SDN network, because most of the time ARP broadcasts caused for some loops. That's why we disabled it, and instead of it, our proxy ARP application received the ARP request and replied to caller directly.
Yeah, but I think the process send the ARP request to the to the infrastructure link, because I think you won't forward the ARP request to the other switch, because it already knows there's another switch. You just forward the ARP request to not link ports. You know what I mean?
Yeah, so I mean,
so you shouldn't generate any broadcast storm, I think.
yeah, I mean, this is interesting, right? Because I mean, we, or at least people who work on Trellis, decided to completely offload the ARP handling to the
Yeah,
data plane,
also,
while, for example, NATSI has a use case for having that supported by the control plane, right? Avoiding like the so-called ARP storms and maybe loops. That's interesting. Maybe we can ask Sora.
But I think I didn't mention that it's clear. The broadcasting means broadcast to the same subnet, which we already config inside the new configuration. So you only send the broadcast to the ports we configure. It won't broadcast to the other ports.
Oh yeah.
Yeah.
Yeah, I don't know if that was clear. It's a controlled broadcast.
Yeah.
But yeah, again, this is interesting, right? So here we have motivations for different approaches. Maybe we can ask also Saurav to understand why he decided to implement it this way.
Yeah, the main reason we disabled the broadcast because we need to connect SDN switches with the legacy switches. When you do that, there must be lots of problem because of the broadcastings.
Oh yeah, so, if you bring legacy switches in the pictures, then it's different. I see.
Yeah.
Okay.
I see. Yeah, but as I said before, this work it's also needed for supporting layer 3 multicast, which is a feature required by our cord.
Yeah, that is one thing that we didn't implement.
Yeah. So if you're interested in to work on that, please let me know. Otherwise, there are these other tasks. So support a PVC unicast, work on the DHCP relay, and the vRouter.
Is it possible to run in our own lab the same demo that the Ying has done?
Yeah.
Then we can digest the implementation and understand better.
Yeah, I think we already sent some instructions on how to run it, and I think Asin was working on that. Maybe you can follow up to the email if there are other instructions.
I can update the email, but I think almost sent.
Okay. Okay, so I think we should move on because we're running out of time. Regarding INT, Serkan, do you want to talk about it?
We have 15 minutes. I have a long presentation, and probably we'll need more time. But
yeah, so
let's talk about the Int.P4 source code and the Kevin's implementation. Then give me a 5 minute, then I can go through our presentation.
Okay, please remember to add the link to the document.
I already did it, by the way.
Where's that?
In the comment section.
Oh, there you go.
Yeah.
Okay, so in terms of updates, yeah, I mean, I wrote these 2 items. I don't know if there's any other updates. Jongwon has been working to upload the P4 code for INT to Garrett. Is there anything Jongwon, you would like to say about this?
Yeah, so I implemented the INT.P pipeline using P4 16, using the latest spec. So you can play with the this code using the BMP2 and the CLI to install some kind of flow rules, and then you can see how the INT works. How the INT add the header, add the metadata, and how to parse the INT metadata stack. Yeah, that's all.
The important thing about this INT.P4 program is that it's the INT tables are let's say the whole pipeline with the INT tables, it's already supported by ONOS for basic forwarding. So you should be able to run ONOS using the INT.P4 pipeline and have and for example, use a reactive forwarding application to, again, forward packets. And then you can program independently the INT tables to start generating the telemetry data. Then Kevin, I don't know if both Kevin and Nate, you work on this? Just Kevin. So Kevin has uploaded a patch in Garrett in which implemented deserializer for INT packets that would be used when ONOS received the INT packets. Is there anything you would like to add regarding this?
No, but I currently just test my deserializer by manual construct the INT packet by making a binary array.
Okay.
I think I will test my deserializer by making my maybe real INT packet generated from like Zhongwen's INT.P4.
Okay. The question I have is the following. So right now you're able to deserialize a version of INT that is not standardized, right?
Yeah.
So maybe you should find a way to tie, this deserializer implementation with the INT specification work going on by the application working group. Yeah, so these were the two updates from Jongwon and Kevin. Serkant, I think you, if you just want to show the slides such that you give a brief introduction, then we can provide comments offline.
Okay.
Perfect. Just the
I
highlight
can do that.
slides.
So I started some preliminary work for the design proposal in ONOS. So I wanna skip the first couple of slides. This is about the INT specification, the information digest from the INT specification.
Mm-hmm.
But the important part here, the reporting architecture, this is a new specification from the P4 application working group, and they define three different tables. Basically, they are not saying these are the tables, but for me it's tables. There are three different tables which are flow watch list, drop watch list, and queue congestion. They're basically flow watch list is an access control list to put the flow rules to which packets will include the telemetry reports, and a drop watch list table will also be a like access control list that's gonna be used for dropped packets in this watch list. And the final table, I'm sorry, table is queue congestion, which when the congestion occurs, the source source switch have to generate telemetry reports for that packets. So in our implementation, we need to have three different tables to conform with the specification.
So are these tables already supported by the program that Jongwon uploaded?
No.
No. So this is something new, right? That was introduced recently.
Yes, it's very new.
Okay.
And this is the general architecture in reporting. As you know, there's a source switch, and this switch has the watch list, like the flow watch list, drop watch list, and queue congestion. And the endpoints switch will generate the reports and send it to the monitoring application. But also this switch may have some filtering to send the reporting. We may not need to send the reports for all the packets. We can define some filters. For example, what can be the filters? If we saw a change in the latency, we can decide to sending the reports. And another example could be if a packet comes from another path than the previous one, that could be the example events. And definitely, this should be also configurable when the device start to generate the events, telemetry reports, sorry. And the spec also says that the reports will be encapsulated by UDP. So basically, there is the Ethernet, IP version 4 or version 6, and UDP. And after that UDP packet, we have to insert a fixed header, which is named as telemetry report fixed header, and we may include another header here, the telemetry switch local report header and telemetry drop report header, or we may not to include these ones and directly put the original packet here, and the original packets have the INT headers. The reason that why we have another header is the sync switch here may not want to insert the INT headers into the packet payload. So if that is the case, then the sync switch just directly inserts the telemetry switch local report header other than inserting to the payloads that INT header. Any questions so far? I am trying to be fast.
Yeah, I mean, I don't think you have to explain everything. Just want to make sure that people here understand what are the purposes of the slide, so they can comments for the parts you want.
I also stumbled upon a very nice paper you can check from this link, and it has some measurements. For example, in 10 gigabit link, a router creates 2 gigabyte per second if just only includes the packet headers, and 328 packets per second is generated. So if we want to handle INT telemetry for all the packets in a 10 gigabit link, then we have to deal with this type of traffic rates. And the current INT design requires the full packet headers, and that is needed for the flow correlation. And that means that we may need to have a powerful collector to parse all these headers, and also we have to avoid using the control plane in the switch to avoid using device CPU resources.
So when you say report generation, is that the process of aggregating the INT data, or you mean you're being able to send the INT data bypassing the switch control plane?
Oh, you are asking for the correlation or
the second part? I'm not sure. I mean, I understand what you mean with implement report generation in data plane.
All right. So if we send this packet generation, if we generate these packets in the control plane, using the switch CPU, then we'll have to need more very more powerful CPU in the switch.
So is there already P4 code that does this?
No, I don't think so.
Okay.
We can contribute for that part. We may implement and contribute to the maybe P4 application group.
Yeah, so we're running out of time. So would you like people to give feedback on the slides? Are you still working on this? You maybe prefer to wait a few days, or do you want to proceed?
You are asking to me, Carmelo?
Yeah, second.
No, this we can think this as a final. People, if they want, can work on this presentation. Just another thing, there are a couple of collectors in the open source, so I find these links as a collector. So I may need help to inspect all of the collectors which can be useful for us. The OPNFE barometer project is looking very good, by the way. Maybe we can reuse this collector.
Okay, so maybe Kevin, Nate, you can help second on this.
Yeah, I will send a mail about this help.
Okay.
This is the network configuration we discussed on the mails. And so all the switches uses the management switch to send to use P4 runtime, and we'll need to create another network on the data plane as another network for connecting the collectors and sending the telemetry reports from that path.
Okay.
Okay. Okay, I'm done. Thanks.
Okay, looks very promising. And these are the slides you would like to present to the TST, ONOS TST?
Maybe I could include 1 or 2 pages for the A-chord alignments.
Okay, so I think in that case, if you want to present something to the ONOS TST, I think you can cut short on the details of INT, like the adders, the specification. And I think there we need to provide more details on how this is going to affect ONOS. So about the API to program the telemetry collection process, which new module we need to implement. So I think we need to spend some time also in defining the ONOS architecture to support this. But this.
All right.
Yeah. Okay, so thank you very much, Serkant.
You're welcome.
Yeah, we are already out of time. So the last. So the last point was about unit tests. I've been in touch with Akbar and Mehmet last week by email. I know they're working on implementing some unit tests for the new, both for the P4 runtime controller and for the new P4 info parser and model. I don't know if they're online. Yeah, Akbar is online. I don't know if you want to comment about this, if you have any update. Otherwise, we can follow up via email.
Oh, by the way, so currently the sonar system is crashed.
Was down?
Because due to the ONOS problem. So currently I think the sonar is still not up. I mean, yeah, they're still not available.
Okay, well, but yeah, that is used to assess coverage.
Hello?
Yes? Bear?
Can you hear me?
Yes, very well.
I have very poor connection, so we We are working on the unit test for now, but we don't have much progress for now because we have other priorities to focus on.
Okay.
But we are planning to start the implementation from tomorrow. So.
Okay. Okay. So please feel free to ask the mailing list if you need help. All right.
Okay, we will. Thanks.
Okay. Okay then. Thank you, everyone. Talk to you next week. Bye.
Thank you. Bye bye.
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 Thanks. Bye.
Thanks. Bye bye.